Okay, correlation and regression, page 5 and 6. So basically, the last half of page 5 and all of page 6 are similar problems, so I'm just going to do one for you, and then you can see how to do that one, and then the others are going to be done in the same manner. Of course, you don't have to do them all, just do as many as you think are necessary to be comfortable with the procedure. Okay? Um, so we're going to be doing 5G number 1. The table shows the distance traveled by a train between various places in India and the cost of the journey, with the distance above and the cost below. Find the correlation coefficient R and comment on your result. Find the equation of the regression line and use your equation to estimate the cost of a 1,000-kilometer train journey. Okay, so what is a regression line? A regression line is like a best fit line that you've been drawing with your eye. Okay, the only difference is a regression line is calculated mathematically. So it's, no matter who does a regression line, everyone's going to get the exact same value based on the same data because there's an exact procedure to do it. Whereas a best fit line by eye depends on the person. You might get a line that's a little bit different than somebody else. Okay, remember that whenever they give you a table in math studies, the first one they want you to use for x and the second one they want you to use for y. So x would be the horizontal and y would be the vertical coordinate. Okay, but in the case that you're just doing it with a calculator, you're going to put the data into stat edit, and I'm going to put it into L1 and L2. So I'm going to clear L1, and then I'm going to clear L2. And then I'll go into L1 and I'll start putting in the data. So the first one is 204, the next one's 1407, so I'll put 204, 1407, and so on. And I'll do this offline and then come back in 2 seconds and I'll be done. Okay, so I just put in my data into L1 and L2, and now I'm going to find the correlation coefficient R. And remember that to find the correlation coefficient, you always need to have your catalog diagnostic flag on. So I'm going to take you down there and show you what that looks like. There it says diagnostic on. So click on that to turn on the diagnostics. Otherwise, the R value does not show up when you do linreg. So then we're going to go into stat, calc, and you don't need to do that every time. Once you do it, it'll be okay until you reset your calculator again. X list L1, Y list L2. I don't even need to change those because L1 and L2 are the defaults. Okay, but if I did need to, I could change it by doing second L2, for example. Okay, store regression equation. I want to put this equation into my y equals memory. So the way I do that is I do a alpha F4, which is this one here, and then I say, oh, I want to put that into Y1, so I click on Y1, and then I press calculate. So not only will it show me, not only will it show me not only will it show me the R value and the equation here, but it's also going to put the equation into my Y equals table. So first I'm going to note that the R value is 0.994 because it asked me that. And 994, this would be a strong, positive, strong correlation because it's between 0.75 and 1. And the equation of the line is y equals 1.469 times x plus b is 116. Okay, and then it asks to use the equation to estimate the cost of a 1,000-kilometer train journey. We can do that because we have already put our equation into y equals. We can see it right here, right? There it is right there. Excuse me. And so I'm going to graph it just to see what it looks like. Oh, and make sure that, let's see, we got two equations in there. I don't want to print out this second one, which has nothing to do with this. So Now that I have both of these, now I'm going to graph. Maybe it'll take a little while. Maybe it's not even going to show up because, you know, I have like a huge value here. It's the y-intercept is 116. I only show a little bit here. I'm going to have to do a zoom fit to see anything. And you don't have to graph it, but okay. So there's my line, and I'm going to use my line to estimate the cost of a 1,000-kilometer train journey. And I think that I need to make it much wider than this to get to see where the 1,000-kilometer train journey is, because this is probably only like 10 here. So I'm going to change the window, and I'm going to change the X max to like 1,200. Now I'm going to graph it again. And now I'm going to do a trace, and then I'm going to give it the number 1,000, and that'll tell me what the y value is when the x value equals 1,000. And since I put the distance in for x and the cost in for y, I need to put 1,000 in for the x value in order to get the y value. Okay, so I can do a trace, and I'm going to change the value to 1,000. And it'll tell me that for an x value of 1,000, the y value is 1585. Okay, so the answer here is 1585 rupees. Okay, and I can also see this on, for example, the table. I could do second table, and I could do the same thing. Okay, but here I just use the trace value. Okay. Oh, and I can try to make sure I see the line itself by adjusting the window size. So I could change the window size to, for Y max, instead of 30, I need something much bigger, like 2,000 for the Y max. Now I'll be able to see it. Okay. There we go. So now if I want to see my point at x equals 1,000, then I go trace, 1,000, and then there it is. There's my point, 1585. And all the other problems are pretty similar to that, okay? The only difference may be, so if you take a look at number 3, the only thing that's a little bit different about this one is that you can see that it also asks you for the standard deviation of x and y. Where would you see the standard deviation? You would see that if you do a stat calc 2-bar stats, and we've already looked at the x bar and the y bar values, but we're also going to see that there is a standard deviation x and a standard deviation y. Okay, so you can find those two to put in for here, and then if you go a little bit farther down, it asks to estimate how many seconds it will take for a swimmer with arm length 70 to swim 200 meters. And look at the y value. The y value isn't